So in this video, we will be discussing about why clay generally destroys the GPR signals. This is one of the most common reason why there is a poor penetration of the electromagnetic waves into the ground. Say example, when you take a clear glass and you put some light on it, the light passes through it easily. And when you are keeping an unclean glass like something covered with mud or anything, the light doesn't pass through it. The same way, the GPR, when the clay is present, it doesn't let the radiation pass through it. And this is one of the major problem what all the surveyors generally face during the survey. Sometimes you can use an expensive GPR system also, and you think like the data is good, but still we have a problem because the presence of clay. Now here we'll understand why clay is such a problem. In this example, the materials all have the same dielectric and therefore the signal travels at the same speed. But you can see here dry sand, dielectric and low conductivity, and again you have the clay also example. Now for the good penetration, the wave must travel deep and also return back to the receiver. But clay rich soil generally they behave differently because they have the permittivity which we were discussing in the previous video. They are different. When it is a dry sand, the permittivity is good, but when it comes to the clay, the permittivity is low, and the permittivity will be different. And the main reason is clay usually contains more moisture, and it also contains dissolved ions, and moreover, this has higher electrical conductivity. And this higher electrical conductivity is a negative thing, like it's not suggested for the GPR because here if you see just an example. So you see a sand layer and a clay layer and also the water table here, because instead of allowing the wave to travel through the ground starts absorbing the energy, and this we call as attenuation. In simple words, the signal becomes weaker and weaker as it travels. So here the clay, because of the clay and also the water content, the waves will lose energy. That means the penetration will be shallow. See, like here, the penetration will be shallow and the reflection will be weak and the image quality will be less. So if you go to this image again, say example, the velocity in the sand or a dry soil is 0.15 meters per nanosecond, and it generally gives you a depth of 7.5 meters, just for the example. Now if you go to the clay soil, here this clay soil you see the velocity itself is very less, or it is different. Say example, it is 0.07 example, that means which is far least than compared to the dry sand. Then you'll have half the distance, like example 3 meters or something like that. So the same travel time, but they have completed the depth differently. But the problem is even worse because in real time clay environment, sometimes the signals are very weak. They don't even come back to the instrument or the receiver. And beginners thinks that okay, no reflection means there is nothing underground. But actually, the signal may also indicate you that there is a presence of clay. Okay, and this is why you have to understand the ground condition before going for a survey. If you can get the data, you can collect the data of soil type, the moisture condition, and also the conductivity of that particular area. And before choosing the instrument also, the GPR also, You have to choose the antenna frequency and the survey method how you are doing, and also the interpretation strategy also you need to consider. So it doesn't mean GPR is useless in clay, because sometimes you can use the lower frequency antennas. Sometimes you can go for the shorter survey depth, or you can also go for some integrated methods which will help you in getting the useful information. But compared to the dry sand or rock, clay is definitely one of the toughest environments for the GPR. So, in the next time when you see poor penetration in the GPR, it doesn't mean the instrument is not working. You have to make sure that you got the proper deep or subsurface data first before going for a survey. And in the next video, we will learn about the frequency change penetration and also the resolution, which is most important decision in every GPR survey. And regarding the images here, in the first image, if you see, there is a same frequency of 400 megahertz, and then it is showing that GPR waves are entering into the ground. In the dry soil, the waves are traveling deep, and in the clay, waves are quickly weakening. That means clay is absorbing the electromagnetic energy. Here, if you see the dry sand and the clay comparison, dry sand is having the deeper penetration, and clay soil is having the shallower penetration. And also the here the borehole data, if you have, we can take the data, and you can find out the unsaturated zone or the capillary fringe, the saturated zone. From that you can also understand like how the GPR traces are changing. So this is one more example, like you do it on the water, and this is how the value and velocity and time will be. And this is one of the example, like to find out. So example, we are working on a drainage pipe. So in the ground surface, you can see because it is unsaturated soil. After that, you can find out in the saturated soil also. But the presence of moisture should be taken into consideration. And there are few potential depths for the GPR. Like see, you can have a look at the table, and then you can also see the scanning direction. It's not just the vehicle, but the GPR will be there. And when you're going in the survey direction, you'll get all the information regarding the cavity or the buried pipes, or a region with the gravels and all. So please do watch the previous videos, and also you watch the next videos, so that you can clearly understand how to use a GPR, how to do the processing of data in GPR, how to do the corrections and all. Thank you for watching.